Of course.
This section has a lot of ties to AP Calculus. Or if you're a senior and you need to take calculus next year, you will see a lot of this stuff in your course. Yeah?
So what's the difference between Calc AB and Calc BC? Do they cover this?
Let's do that later since we're doing a video.
Oh, you're right.
Let's focus on the material. I can answer that after we're done. Let's go through some of that vocab first that you guys saw in the warm-up. So we need to know what a turning point is. We need to know what a maximum is, a minimum, increasing intervals, and decreasing intervals. Okay. There are some very, very fancy and formal definitions with inequalities and all this stuff, but we're just going to go through more of an intuitive understanding, like just being able to look at a graph and say, oh, this is the turning point. It's increasing from here to here, and here's the highest point on the graph, so the maximum is this. It is easy. So let's just draw a little sketch here. If you guys can follow along. Let's say we have a point at 0, 3, and then at 1, 4, then at 3, 1, and then at 4, 5, and then we'll go to 6. Sure. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And let's say the graph looks something like this. Okay? Let's label these points. Let's call them A, B, C, D, and E. Let's start with turning points. You guys in the warm-up did a nice job. Let's see if we can do it again. Where are the turning points here? Go ahead, Pat. Thank you, Patrick. B, C, and D are correct. I mean, it literally looks like the graph is turning around, right? What's going on from A to B? The graph is increasing. And then as soon as it hits B, right after that, what does it do? Decreases. In fact, that's what a turning point is. It changes, the graph changes from increasing to decreasing. Okay? Well, not necessarily, because I could have put another point here. Thanks.
So are they like the tip?
Erica and Steven, can we pass these back? What's that?
The tip and the bottom?
Yes, they're usually like tips. That's a good way to think about it. Yep. Maximum. Some graphs that go towards infinity or negative infinity don't have a max or a min, but this clearly is stuck between two values, right? What's the highest value that you see for this graph?
6. 5. 5, sorry. 5.
So it's the point D, but for a maximum, we always write the y-coordinate down. Okay, so whenever we ask what is the max, what is the min, it means tell me the y-coordinate of that point. So yeah, D is the maximum point. What's the y there? 5. What about the minimum?
Minimum 1.
Minimum is 1. Good, because the lowest point on the graph is C, and then it has a y-coordinate of 1. Does that make sense, everybody? Okay. Increasing Means as we read the graph, just like a book, from left to right, the graph is going up. So from what point to what point is it increasing? From A to B. Okay, so now let's translate that to x's. What's x here?
3,
Careful. X is 0, right? 0 to 1, it's increasing. From B to C, we are decreasing, but from C to D, it's increasing. So from what x to what x? 3 to 4.
Why do you write it like
How's
that?
it through?
Because I'm just listing the intervals where it's going up. This is interval notation, right?
Oh, okay.
Decreasing. Bless you.
Wait.
From B to C, we're decreasing, right? So what are the x values there? From
4 to
From 1
to 3.
to 3. X values. X, not Y. And that's actually a good note to make. We're always talking about x's here. When we're saying where are we increasing, where are we decreasing, you tell me from what x to what x.
So maximum and minimum is y.
Yep.
And the other ones are x.
Yep, very good. Let's write it down. Are we decreasing anywhere else?
4 to 6.
Does everybody see that?
Yeah.
4 to 6, very good. Okay. I use parentheses. Some books use brackets, but here's my philosophy. B is a turning point, right? So I argue that at B, you're not increasing or decreasing. You're at the top, right? It's right after that that it starts to go down or starts to go up. Okay. Any questions on the vocab? All right. So here's one of the 3 big things you need to know. Average rate of change. Let's say we have a graph. And it looks something like this. Let's call it f of x. And let's say at a, x equals a, we have a point. And at x equals b, we have another point. See if you guys remember. What coordinates does this first point have? What's x?
A.
And what would y be?
F of X.
Not f of x,
Just X. F.
f of a. Very good. Right? Because to find y, you'd have to plug in a, and that's what this means. F of a means plug it in and figure it out. Okay? What coordinates would this have? B, f of b. Okay. And let me just refer to this example here that we did before I talk about this real quick. If I asked you, let's say right here where my orange pen is pointing at, what kind of slope would this curve have? Everybody thinks it's positive?
Negative.
What about right here?
Positive.
What about over here?
Negative.
Okay. Have you guys talked about average slopes or instant rates of change in physics yet?
Yes, acceleration.
Okay, have you done like tangent lines?
Yes.
Oh.
Okay, we're not going to do tangent lines. Okay, we're going to leave that for calc. But what we're going to talk about instead is an average rate of change. Meaning that right here at A, what kind of slope is this?
Positive.
Positive. What about at B? Still positive, but do we agree that the slope changes
Yes.
as we move along here?
Yeah.
It's not always the same slope, right? But what we can do is if I connect A to B, like this, straight line. So if I connect and make a straight line or a straight segment from A to B, if I find the slope of this purple line or purple segment, that equals the average slope. which is just another way of saying average rate of change. Rate of change and slope are synonymous. Okay? You guys know how to find slope. You did it on the warm-up with numbers. If I asked you to find the slope from this point to that point, what would you do? Oh, this needs a parenthesis here. Sorry about that. How do you find the slope from one point to this point?
Y2 minus Y1.
y2 minus y1. Great. What's y2? F of b. So let's write this down. Average rate of change equals f of b minus, what's y1? F of a. Very good. And then over? x2 minus x1, which is b minus a. This looks like a fancy schmancy formula. It's really just slope. You're just finding the average slope, okay? So don't think this is confusing or hard. It's really not. It's just the notation looks a little different. And now we're doing slope questions for things that are not just lines anymore. Okay? Are there any questions on how we found this?
But wouldn't that just equal 0?
Why would it be 0?
Because the B and A cancel out. Just kidding.
Let's do should we do an example here? Let's try an example. You guys can go make music in the hallway if you want.
Yes, Jay.
Find the average rate of change on the interval 0 to 2 for the function f of x equals x squared minus 3x plus 5. By the way, what interval was this picture for? From A to B. Very good. So, the interval for this formula corresponds to the interval from A to B. Yes, Erica?
Is there like any specific reason that they're in brackets? Like, does it really matter?
Well, if they weren't, then we wouldn't actually have a point there.
Oh, so okay, C is the bracket. Okay.
Yeah. All right, so now how do we do this? Well, if we know we're finding average rate of change, you guys figured out a formula for it. So I'm just going to start by saying, okay, I'm going to have to calculate f of b minus f of a over b minus a, and then I'm just going to plug everything in. What's b in this scenario?
2.
Good. So if it helps, put a little a and a little b by the numbers so you know what's what. So now we do f of 2 minus f of 0 over 2 minus 0. So now this means something. This f of 2 represents a y-coordinate. We got to figure that out.
You just plug it in.
Yeah, that's right. You just plug it into the function. So I'm going to put parentheses and plug in 2 squared minus 3 times 2 plus 5. This stuff in the parentheses is going to give me the y-coordinate for this first point. Does that make sense?
You're going to have to plug in 0 too.
You're also going to have to plug in 0. So subtract, and I always use parentheses so that we don't make a mistake distributing negatives and such. Plug in 0 squared minus 3 times 0. Again, I'm showing more work than I need to, but that way no one is confused. And then what's 2 minus 0? Well, that's just 2. So now we just clean everything up. 2 squared minus 6, negative 2 plus 5, 3. So we're doing 3 minus 3 minus 5. 2 minus, or this is negative 2, right? So this average rate of change is going to be negative 1 here. Bless you.
For the interval, like where it is 0 to 2,
Yep.
are we going to have like equations like x plus 1?
Oh, yes. That's a great question. In fact, let's do one. Okay? Because in calculus, it's all going to be variables at some point. Right now, we're just gaining an understanding for what you're calculating. Let's say we have, again, find average rate of change for f of x, and let's say f of x this time is x squared plus x, and the interval is not just the numerical interval, but let's say I go from
Knobs.
1 to 1 plus a. It's not that hard. It might look a little intimidating at first, but it's the same thing that we just did, right? How do I set it up?
Oh,
What's a here?
so that's
A is 1 and b is the 1 plus a value, right? So how do I plug everything into the formula to get started? It'll be
first one will be 2, right? X, 1,
f of
1.
1 plus a minus f of 1 all over 1 plus a minus 1. So all I'm doing is plugging this stuff into the average rate of change formula. You got to know that formula. That's the easiest thing to do. It's just write it in terms of the formula and then figure it out. So now what does this mean? F of 1 plus a means to take 1 plus a and stick it into where?
X squared plus x.
Into the x in the function here. So let's do that. It's going to be 1 plus a squared plus 1 plus a. So that's my first y value. Minus, hi,
Sorry.
good, oh no problem. Okay, hey, can you pass that over to CJ, Elliot? So now we plug in 1. We do 1 squared plus 1. Somebody said 2 already. That is correct. What happens on the denominator?
A.
You just get a. Very good. So now we're going to clean things up as much as we can. If I square 1 plus a, what does that become?
1
Plus.
2a plus a squared.
You guys are getting better. No one's saying 1 plus a squared anymore. Plus 1 plus a. Let's distribute. And this is 2, right?
Yeah.
So minus 2 all over a. Keep cleaning things up. And here's the nice thing. With all these problems that we're doing with average rate of change, and when we do different quotients in a minute, you're going to see a lot of stuff cancel. 1 and 1 make 2. If I subtract 2, that goes away, right?
wow.
What can we do with a squared, 2a? Let's write it in order, maybe. Actually, 2a plus a, I can combine that, can't I?
3a.
That was silly. Let's do that. A squared plus 3a over a. Can I do anything else with this?
3 plus a. A plus 3.
How'd you get that?
Divide by a.
Divide by a.
Take out an a?
Yeah.
Oh, wait, no, just divide by a.
Can't you divide by the a on the bottom?
You can, but you guys have a tendency to make a mistake when you divide fractions like that. So I'm going to start doing it like this.
Doesn't matter if it says a plus 3 or 3 plus a.
No, it does not.
It's just A plus.
Bang.
Okay. Any questions on that? So you should be able to handle numerical values, or if I give you intervals like a to b or z to zebra, who knows? You should be able to plug them in. Elliot.
So instead of using FB minus FA something, we just pretend like it's Y2 minus 1.
If it helps you, sure.
Alright.
Yep. Okay. Last part, difference quotients.
Is this going to take up a lot of room?
I have about a page worked out, but I write kind of big. Sometimes I have skin and bones for the notes. Sometimes I work through everything if I change what I'm doing.
Does it say difference or inference?
Difference. Sorry, it was off the screen there a little bit. Difference quotients. There are two types. One is f of x minus f of a all over x minus a. And the other type is f of x plus h minus f of x all over h.
All over to it.
What does this look like to you?
The same thing we got up there.
The same thing we had before, right? What's the only difference?
Those
It's
different
X,
variables.
not A.
Different variables. Cool, let's write this down. It's the same as the average rate of change on interval, what? From what to what?
A, B.
A to B.
Well, normally in the formula it's A to B.
A
What's my A and B here?
X and A and X.
A and X. Do you guys see that? That it's the same thing if you plug it into that formula we did? Okay? So here's what I want you to realize is that difference quotients really do represent average rates of change still. They're just more algebraic and just a different way of looking at it. And this is the stuff that you're going to see a lot of in calc. Especially this guy right here, this f of x plus h minus f of x over h. This is huge because half of calculus is from this difference quotient here. You'll see what I'm talking about next year. What interval is this going to, or going from? From, what's the a value here?
X.
X, and what's b have to be? X plus h. And, you know, I know the denominator doesn't look quite the same, but if you take b minus a, do you guys see that the x's cancel out? Okay, so it's really still, you know, b minus a on the bottom. It's just that the x's dropped out. Okay? So, again, it's just plugging stuff in. It's not very hard. Just take some practice. Here's an example. We'll finish with one example and we'll do both problems, okay? Find both difference quotients for the function f of x equals x squared minus 5x. Okay? Yes?
What's the difference between the two types? So, like, okay, I know the difference, but will there ever be a case where you're supposed to use one instead of the other for, like, a certain situation or anything?
Yeah.
No. I mean, for you guys right now, it's either going to say like this, like, find this difference quotient. What does that equal? Or find this one. What does this equal?
So they'll tell you.
They'll tell you which one to use, or it'll say, tell me the average rate of change from a to x, at which point you'd have to get this on your own, but you can if you know the definition. Does that make sense? Okay. So let's find the first one. And here's where you're going to see that a lot of stuff always should cancel out if you're doing things right. So if I plug stuff in,
But you didn't give us an interval.
no, because all I said was just figure this out.
Oh, okay.
So there's two ways I can do this. I could either say, tell me what this equals, or I would give you the interval, in which case your first step would be to write this down anyway. Does that make sense?
Sure.
All right, so let's plug in everything. What's f of x?
5x. Just 3.
It's just x squared minus 5x. Nothing new there. Minus f of a. What's f of a going to be? Plug in a into the x's. What do you get?
X
A squared minus 5a.
Very good. All over x minus a.
Oh, that's
Wait, can you explain what just the case?
All I did is plugged in a into the x's.
Oh.
You know how instead of f of 2, and we plug it in and figure it out, now we're plugging in a.
Wait, but. Oh, never mind.
But
No,
before,
wait.
before you didn't do
It
that.
wouldn't make it x cubed.
Oh, I get
because
you.
you plugged it in. Never mind.
that makes sense.
Erica?
Does the bottom stay x minus a? Or
For now, yes. Because we don't have anything to do with that yet. But let's see what happens. Let's put these two squares together, shall we? X squared minus a squared. Let's put those at the front. And let me put everything else after that. So minus 5x. And if I distribute the negative here, what's the next term?
Plus 5a.
Plus 5a. Remember I said stuff should always kind of cancel out, but I don't see anything yet.
You got factor, right?
Yes,
Grouping.
factor, grouping, sure. How do I factor this first part?
Square. Yes.
X minus a squared.
It's not x minus a squared, you're close.
X minus A.
X minus a,
X plus a.
x plus a, yeah, it's difference of squares. Bless you. What could I do with these last two terms? Take out a negative 5, and what's left? Careful.
Wait, no, yeah.
It's x minus a, because negative times negative gives us positive 5a, right? Yes, they will cancel. And again, for those at home, so that you don't get confused, I'm factoring out the common x minus a.
So just left with X minus
And what's left if I factor this out?
negative
If I factor out x minus a from both terms, what's left?
X plus a.
X plus a
Minus 5.
minus 5 all over the x minus a that we had before.
Is there a reason you put X
Say, wow.
No.
Totally lost me.
I have no space on my paper.
So there's the answer.
Turn the sheet, CJ.
Wait, so you're canceling out the first and the last X minus A?
Yes, because it's common to both terms. So what I'm doing is taking it out as a GCF, putting it out in front, and then writing down what's left over.
It's easier to cross things out, Mr. Chief.
Yeah, but you guys make mistakes when you do it that way.
How about 32nd?
But you only have a 4.
Alright, I'll
We
take
have
4.
to
Wait, is there timeouts?
All right, you guys are lucky. I may be able to finish everything for your quiz tomorrow.
We're still not done?
No, we got one more. It's the same problem. We just haven't finished it yet. Now we got to find the other difference quotient.
And we're going to have to do this for every test.
Mm-hmm.
Oh, let's do it then. Yay.
Okay. Not hard. You all right? When I have x plus h in here, that means to take x plus h and plug it all the way back in to the x's here, right? So let me write it down carefully. My first thing should be x plus h squared minus 5, and now instead of x again, another x plus h. Is everybody with me? What's wrong?
Why is it just...
Because that's what I'm plugging in.
Just plugging it back in.
I'm plugging it back into the original function here.
Oh, oh.
So instead of x, I'm replacing it with x plus h. Does that make sense? Minus f of x. This is not anything new. We already know what f of x is. What's f of x? X squared minus 5x. I just write it down. All over h. And then from here, it's just algebra, but you have to be careful. Let's square this first term carefully.
X squared.
X squared plus
2x.
X 2x
That's
h
2xh.
Mm-hmm.
plus
Plus h squared. Distribute the negative 5.
Negative 5.
Negative 5x minus 5h. Distribute the negative here. Plus x squared plus 5x. And look, a lot of stuff dies. That's good news. Well, in math, things going away is good. Not in real life. What cancels out?
Unless it's
We're
a
not
goal.
the X.
Whoa. Hold on a minute. Hold on. Big mistake back here. That was a negative x squared. Did you guys make the same mistake I did?
No, I can't.
Of course.
Good.
Never make this.
I'm a check.
Never.
We're not
What do
math
we do?
teachers.
I distributed the negative incorrectly. I had a plus here. It should have been minus x squared and then plus
Alright,
5x.
so those
We're
cancel
losing
out.
precious minutes.
Oh.
So what cancels? X squared.
5x.
5x. Let's write down what's left. 2hx plus h squared minus 5h. Everything has an h. Take it out.
You can.
Cross it out. So there's your answer.
You just cross out the h's?
It's gonna 2x.
Oh, sorry.
What?
So I took every term had an H. You guys see that?
Yes.
I pulled it out, wrote down what was left, and then I crossed out the common terms, which are H, and there's our final answer.
Okay, so for both of those, you ended up getting a -5 in the end. Well,
That's some